Hi, good day everyone. Today we are going to start with the Docker tutorial. It's not a tutorial, but we are just going to take a look into it, what Docker is and how things works in Docker, why do we need it. So I have portrayed an agenda over here like as you can see here in the screen. Let me just maximize it. Just give me a moment please. Okay. So as you can see, we are going to look into what is Docker and then followed by what is containerization. Then we would understand the difference between virtual machine and container, followed by differences and similarities. Or we would talk about like build tools that we have like Ant, Maven, or Node Package Manager. So what is the difference between Docker? Because it has a sort of inclination towards Docker. So we will discuss those things in our session today here, and then we will take a closer look into the Docker architecture. Basically, it's a client-server architecture, which is most of the applications are, which are at the enterprise level applications. If you develop website or whatever site you are gonna develop, mostly it's not mostly, but at least 80 to 90% of application at enterprise level has this architecture. Now, prerequisite that we have before getting into the Docker is like we need to have a basic understanding of the operating system. So when I say basic understanding of the operating system, you don't need to know everything about the operating system. Like it's a huge topic to discuss or to study, right? I mean, it's not something which happens overnight, and you need to spend time on it. But at least you need to know the shell perspective of the any operating system. At least you should have hands-on on that. In this case, if you know Unix and Linux, that would be very helpful. When I say Unix and Linux, you need to know the shell programming of a shell front, or the CLI, when whatever we say when we talk about the shell, it's a CLI stuff we are talking about rather than GUI. Command line interface, you need to have a good understanding on that. And then basic programming language and the SVN tool or build tool, whatever tool you use generally, because we need to uh, we need an application, right, which you want to run on the Docker, or which you want to contain on the Docker, right? So that's the concept of containerization. So let's get started. This is just the agenda I have just explained you very briefly. uh, let's talk about Docker. So what Docker is, why Docker came into the market. Let's talk about this perspective. See, the thing is, whenever there's two things, right? You have your local system where you develop your code, and then you push your code or the whatever code base you have in your SVN, whatever SVN you're using, be it your Git SVN, be it your Bitbucket, or whatever SVN you're using. And from there, you generally schedule your build by using the build tool like Jenkins, or we have GitHub Actions, right? And then you do the deployment to your production environment. If you talk about the development alone, or when you talk about the testing front of it, if you are doing automation testing, or you are doing some development of the framework, and you have your business application plugged into your framework that you have developed, and you want a build to be scheduled with a single push from the dev side into their repository. You have your framework articulated or orchestrated. I won't say orchestrated, but articulated in such a way whenever developer or a development team give a push to the main repository of the application that you have, and you want your automation built automatically to be triggered with a single push, whatever feature they are pushing to it, their repository. And if you want to your automation suite build to be running, for that we use for that purpose we can use Docker, or the uh, containerization concept. This is just a high level I have explained you, but it has many more important uses, or which important use cases that we have in place. let's say you being a developer, you being a automation, SDET person or automation person who has to write a pipeline, you are developing your code in local. In local, let's say you are using Windows application, you are in local, you're using many things to build your code, right? You might be using Maven as a build tool, you might be using Java as a language, you might be using some any other language like JavaScript or your node package manager. All those things has a dependency on the system you are developing your code, the local system, right? And when you push your code to the environment, or to the server or to the cloud where you have hosted your application, so those the environment you have there in the cloud and the environment you have in the local, there might be a chance when your build has been pushed to the cloud where your applications are hosted, there might be a chance the code might get it might break over there. So to avoid those sort of things, Docker came into the picture. How it came into the picture, this is just the conceptually I'm explaining you all those things. We will see all those things practically when we go into our shell, Docker shell. We would discuss all those things in detail, like how you can install Docker, how you can get the shell, and how you can get the things moving when you talk about when you are in Docker environment. So uh, this is just a perspective about the Docker and the stuff that we have. We can also see Docker as a platform. Platform means it would give you many, it would cater you many functions or many features or many opportunities. I would not say opportunities, many features it would provide you to do the containerization. For example, it has a whole architecture in place. It has a CLI. Docker has its own CLI. It has Docker build. It has Docker compose. So these are the inbuilt tool within Docker itself, which you can use, to do the containerization. Okay, so thus far we have been talking about containerization. We have been talking about Docker. Let's understand what is containerization. See, containerization means, as I was talking about the local system, right? Local means this very system where you are seeing my slide, right? This is the local system. I'm running this PowerPoint in my local system here. So I'm running this slide in my local system. So, and this is the Windows operating system. Suppose I want to run the same slide into the Linux operating system. What are the options I have? One option is you buy another laptop or you get another machine, install Linux into it, and that you start doing whatever. I mean, you can open up PPT over there. Another way is we can use virtual machine or virtualization where your machine are hosted somewhere else. You have been given an IP address. You use that IP address, connect to that machine, get into that machine and do, which already has a Linux into it. And then you can, bring up your PowerPoint or, this PPT in that machine. So another way of doing it, we can use Docker, which would give you a same sort of arrangement of the things in your local system or into the server where Docker engine is installed. What is Docker engine? Again, we will talk later on. So let me explain you in this way. So we have our local system here. We have this local system. I have my machine here. So it is a Windows based machine. And I have a program or a software called B bundled here, software developed here. I want to run this software be in Linux. How I can achieve that? See, one thing is you get another machine. machine, and then in that you install your Linux, and then install your software B here. I mean, pull all the dependencies or whatever things needed to run software B, and then start doing your work. Another thing is you have a cloud somewhere, and from cloud you get your machine, and then which has Linux into it, and then you run your software, whatever you want to run. Another way of doing is we have a Docker as a platform in which you can create a container. You have a Docker. Let me create it here. You have Docker platform here. Here you can build your container having Linux into it, and in that container you can just install or pull your B software and keep running it. So this is what we call the containerization process, and it has a lot of I mean, we have already discussed, like, let's say if I have something in my local system, most of the time it could happen, it has a chance, like, the application which is running in my local system might not run in cloud or in virtual machine. But if I create a container uh, of my software version as an image, so advantage is I can send this image to the cloud, I can send this image to the virtual machine, and build my B application over there without any issues, because that same image I have built from my local environment where I was developing my application. So that's how things gets held up in Docker system. So this is what a kind of uh, when we talk about what is Docker, this is whole the kind of requirement or the basic understanding of Docker system. So let's move ahead. We to next topic. Like, we were talking about the containerization here. Let's talk about containerization. What is containerization? We have already discussed this. You have seen here, like, I have created a container here. I mean, I've shown you the container here in the slide. See, the thing is, in local system also, when you are developing an application needs an environment, right? Environment means from where it takes everything that needs a software to run. For example, let's say you need a Java to run your application. It picks Java from the environment. Your operating system itself give environment to run your software uh, with the help of system softwares, with the help of your application softwares. System software at the low level, we don't want to discuss that, but at application level, we have a Java as a language we install in our operating system, and then we install build, whatever build tool you want to use. In our case, we are using Maven, and whatever IDE is just for to write down code for developing the software. So Java, Maven, these are the your kind of environment entities for your application to run. So same sort of environment I can cater or I can create by using Docker, and that environment we call container. So from that container, now software B, whatever you want to develop, software B will pull everything from that particular container, and then it will run your application or build your application, and you can later on do whatever you want to do, or you want to, wherever you want to host your application, you just have to send the Docker image, and that's it. So this is what the containerization all about. Containerization is also called building up your container by using the image, Docker image. What is Docker image? Again, we will just take a look into it shortly. So far we have discussed about Docker, right? What is Docker? We have discussed, I have uh, told you like it's a platform for containerization, right? Containerization and containerization, what is it? Containerization is nothing but the environment one need to build an application, right? And now container till this we have discussed what is containerization. Fine. How do I build container? That is also we need to understand, right? See, to build a container, we would need something called image, right? So, for example, let's say you have got a new operating system, you have bought a new machine, right? And it's a just bare bone machine. It's just a bare machine, right? What is the first thing we do generally? We get an image, right? Which we call ISO. I mean, if you are talking about Windows operating system, you get the ISO of Windows. That image you run in your operating system to run the Windows application, right? You need an image, right? You need a software of Windows, right, to run your operating system. The same thing or similar sort of thing is images. When we talk about container, image tells everything about container. Image tells image tells which container, which type of container we want to build, right? Which type of container we want to build. Whether you want to build Ubuntu or Linux container, you can, fetch an image. You want to build Windows container, you can fetch an image, right? So that is all, everything is being described into the container. Also, this image we call Docker file. Docker file is nothing but the set of your Docker commands. You would mention it here in this Docker file, and this Docker file you build it later on to bring your container up, right? So I'm not sure how much understandable it is thus far, or how, because I know, I mean, uh, how much it's, consumable from whatever discussions we have so far. But again, we will come back to this later on also in later videos. But just for normal understanding purpose, I mean, uh, you just need to know Docker is like a platform which gives us containerization. Containerization nothing but the environment we need to run our application. How do I build container? We need images. Why do we need images? Example I have already told you, like if you buy a computer, a new system, in that system you need to install a software. So you get a Windows image, ISO, or you install that software. Similarly, image works in same fashion. You need to explain in the image what operating system you would like to use. You mention it into the image, like this operating system I want to use. Image, image is nothing but the Docker file. Again, it's a file. Just understand, it's just a file where you mention all those commands, like you want to, which operating system you want to, your container belongs to which operating system, or which operating system you want to run the container, explain it over there, which all things you need to run your software or run your application. You mention all those things in container step by step. See, it's how do I portray? See, in a layman term, just understand this in this PowerPoint, right? Very PowerPoint, right? Whatever things I have done this to bring up this PowerPoint in the system, in this monitor, right? What did I do? I went to the desktop. Icon was there. I clicked on it. Immediately opened up and showed up into this screen, this monitor, right? So I did this by using GUI, graphical user interface. Imagine same thing I have to do using CLI, command line interface. What do I need to do? I need to go to command prompt. There I need to type a command called PowerPoint, right? I PowerPoint or Binword, or I'm not sure what the command is, but I need to type that command and then PowerPoint will automatically be popping up. Simple thing, the same thing I have to do. Instead of typing it there, I will write down all those steps into the file called Docker file. And then I just need to run Docker build and then the image name. And then automatically container will be brought up, right? So this is what a kind of uh, the basic stuff of Docker. There are many things to discuss about Docker. Like we have to talk about like what is the difference between virtual machine and container, difference between or similarities between build tool like Maven and Docker. I have put up these things just for the sake of making you understand uh, Docker more closely by comparing it with the virtual machine, right? So virtual machine, again, it's just a machine or remote desktop running somewhere in some other location. You want to connect to that desktop. How do you connect? HTTP protocols are there, HTTPS. You can use APIs to connect to that. You need IP address to connect to that server or machine. And then you need a directory structure or shell. You need to enter to the shell of that system. You can bring up. This is all you do to connect to the virtual machine. And one more thing, virtual machine is a full operating system. It has everything, OS, it has its own hardware. But see, the container is not, a container doesn't have everything uh, within itself, right? Container is just a process. Technically, if you want to understand, so yeah, just give me a moment. We discuss about containerization. We will discuss about now virtual machine and container. Just give me a moment. Where was I? Yeah. Okay. It's not clicking. Why? Just give me a moment, please. Okay. Okay. So let's containerization, container versus Docker. Sorry, container versus your, come on. Why? Just excuse me. Sorry. Come on. Container versus virtual machine, VMs. See, your virtual machine is actually it's a system somewhere remotely available. Actual machine, it has its own resources. Okay. So what is resources? See, resources are like it has hardware in place. It has memory, primary, RAM, everything. All those resources are available to the VM, right? It's kind of, not kind of, but it's a actual machine. Only thing is you are trying to connect to that machine remotely somewhere, or you're hosting it in your local. That's what virtual machine. But when we talk about container is just a process. is just a process, and it's a uh, it's just wait, just excuse me, sorry. Yeah, container is just a process, right? So what is process? See, process is a set of subtask, right? Set of subtask, right? You want to do some set of subtask. That is what we call process P. It has everything. It's PID. So operating system, what operating system consists of number of process, right? P1, P2, P3, right? Later on, this process itself can be divided into threads, right? So these subtasks are threads. So anyway, let's not get into this all we don't want to know all those things. Only thing is, we know process is just this is how operating system works, right? For every single task that is being done or whatever things are running, everything is being divided into the process, and process itself has everything. Process has PID, right? And one more important thing, one more important thing is, just give me a moment. Sorry, I had to go somewhere. So I'm back now. So yeah, see, a container is just a process, right? And process, we have ports in the operating system, right? Everything, whatever, even if you hosting your application is also being hosted into the ports. Generally, you host your application 8080 application port, the port number, or there are many ports 8085 in whichever port you want to host your application. So all I'm trying to say, whatever container is being hosted, this container will be hosted in a particular port of of the system where containers are being built up. So here also we need to understand uh, one more concept, like, see, okay, we'll go to that concept later. But for now, I guess this would be suffice. We just need to understand, like, container is just a process, which is very important for you to understand. Just a process which is running in the port 8080 or any port you want to run into, right? And virtual system is the machine itself. It's a full-fledged machine, like, it's not a process, but full a machine somewhere placed, and we want to connect to it, or we want to somewhere in the cloud, we want to pull it from the cloud. That is what virtual machine is. So yeah, that is what container and virtual machines are all about. Now we also have again, this is again kind of a milestone, not a milestone, but why I have mentioned all those things, why I want to discuss about virtual machine and container, differences between virtual machine and container, virtual differences and similarities between build tool, Maven, and Docker. Why I want to discuss all those things? Because these things I mean, these things having an inclination towards the Docker. These things will help you, get a grasp on the Docker concept, get a hang on the Docker concept more closely if you understand these things very little closely, right? So again, Maven tool. Let's talk about this also. Like, what is the difference and similarities between Maven tool and Docker? See, although these Maven and these things belongs to totally a different family, right? See, Maven is just a build tool. It's just a build tool, right? Maven. tells like what all third party APIs you are using, what all third party API you are using to develop a software, right? That is what Maven is all about. Maven has dependencies, right? It has dependencies, right? It has, let's say you want to have uh, you need to have, let's say testng as a tool you want to have. You can use testng as a tool. Let's say you want to have some other API, third party API, POI. So you can mention all those dependencies into the Maven, and that dependencies will help you building up your software. It will pull all the third party applications, whatever things needed to run your application into the uh, your software at the runtime by reading the Maven file, right? Which is nothing but the POM file. Oh, come on, POM file, right? So it helps you developing your software by pulling all those dependencies, adding them as a package to your program, and you can use the functions from that program. That's what Maven is. Similarly, similarly, Docker is also a kind of same thing it is doing, but not at the uh, software development level. Not no, I not at develop, not at the code writing level, I would say. Maven will help you writing the code by pulling up third party dependencies, and from those party you can use the functions. But Docker will help you at the environment level. Okay, so let's say again, we have already discussed it a lot, these things a lot. Docker will help you at the environment level to pull what all things needs to run your application, right? Running things needs to run application, right? So what all things you know need? Let's say you want let's say you are developing on the Node.js. You need Node.js, right? And then you want to use your package manager, NodeMon, right? So you can pull NodeMon into it. Let's say the repository where your code is presented, that repository is Bitbucket. You want to use Bitbucket, or you are using GitHub, right? So all those details you can mention in a Docker file, right? All those things you can mention in the Docker file, and you can build your application in the different environment, or in the same environment you are running. You can check from there whether when you shift your application, it is running in some other environment properly or not. That is what the differences. That is what the difference between Maven and Docker. So let's give a pause here. Let's take a pause here. So far, whatever we have understood, this is just the first video. I'm also kind of new to this annotated this annotation stuff here. So please excuse me for my handwriting. We will see you in next video, and we will cover rest of the topic. So maybe we will revise these things again.